Welcome or welcome back. I know there's a few new people that added the class since Tuesday, and I don't know if, if they're here yet or not. But in any case, I want to do a quick recap of where to find all the course materials, and so that anyone new can get there, or if you have tried already and got stuck, you can get there. Hey, question?
No.
Oh, okay. Can you,
You can sit.
yeah, sit someplace, please. Thank you. So, in any case, the Canvas site for the class, if you've been added anytime more distant than an hour ago to the class, Canvas site should be accessible, and it's all of one page. Stuff's on here. I did add one link on here, which I apologize, I was having video issues on Tuesday, and had to use a program that I didn't really want to have to use. But in any case, there is at least a quasi video from Tuesday, despite other technical difficulties. In any case, so we've got main information here that you need. You've got your syllabus, link to where lecture videos are going to be stored, and a link to the Rational Reasoning website, which is where the actual course materials are. They're not in Canvas. So the Rational Reasoning website, again, has two components to it. If you just click on this link, you'll get to a page like this where if you haven't signed up already, sign up. Let's see. I don't know why that link wasn't showing, but in any case, you'll see a page somewhat similar to this. This is the instructor view of it, but there's two main parts to this. There's the textbook online, and then there's the iMath AS, the homework and activity sort of site, the place where you answer questions. So the textbook itself, I have the instructor edition, but yours looks the same. Looks like this. This is your workbook. But there's other stuff on here in addition to just the what's in the workbook. So you'll see, you can see the text itself. There we go. And we're working in Module 2 right now. Like I said, this text is also used at some area high schools, and they start with Module 1 and do all the, so we're just doing 2 through 8. But in any case, the textbook is here, as well as there's some PowerPoints that you can look at, and you won't see both student and instructor versions of these. But the these are investigations for section 2 and it's a little hard to see maybe, but it's 0, 1, 2, 3, 4, 5, 6, 7. Those correspond to the sections in the textbook, module like 2.0, 2.1, 2.2, and so forth. So we're going to be taking a look at some of these today in here and doing some of this in group work together. Like I said, I wanted to get you a little acclimated to where everything is and have you have a chance to get all the materials before we used a lot of them in class. But typically in class, what I'd like to do is me not talk the whole time and have you do some more talking both with one another and to the group, so that I know that you understand what's going on and you have a chance to practice and figure out what it is that we're doing and to know the content of the course before you leave here, so that it's not a mystery and you're going to go try to figure it out later on your own at home. So in any case, this is the textbook section of Rational Reasoning. The other section is what I had previously right when I started the class. Let's see. Oh, I'll just follow the link again so it opens again from scratch. No, I guess not. I'll just go here faster. All right, so if you click the iMath AS link that's on that instead of the online homework link instead of the textbook link, it goes to this, which this is, yeah. Ooh. There we go. It's not going to send you notifications like Canvas notifications when you've got assignments due, but if you go to this page, you should be able to see upcoming assignments on this calendar that I have right at the top. So I want to talk about the color coding since there's a lot of different things on there right now. Gray is for things that are either past due or not yet available, but that you can see already. And I'll have some more things listed so you know kind of what's coming up. But I don't want you to like jump like 12 sections ahead and try to work through things without us having discussed a little bit in class. So I'll have some things open up a little bit in advance, but not the whole class is going to be open to work on all of it at once. But the things that aren't gray is kind of stoplight coloring. We've got green and orange and red. So red, it's not for different categories of things, it's for how soon it's due. Red means it's due really soon or sooner than anything else, so please work on it. I don't know why this one's green, because that seems like it should be a different color. I think there's something weird about this square, because that diagnostic pretest it's off-site, so it just picked its own color. But generally, things that are due longer in the future are going to be green. Orange is, hey, pay attention to this, it's coming up soon, and red is, get to this right now. So, I mean, not right now, but by 11:59 p.m. tonight, you can click on the calendar just like I'm doing. You can see what most of the due dates are 11:59 p.m. There might be things that pop up that we're going to be doing during class, so I'll just have some sort of other random time set. But in any case, this 2.1, that parentheses LN, is for lesson. So if you look down below in Module 2, so this is 2.1, you can see that for Section 2.1, there's a lesson and there's homework. So the lessons are kind of wordy. There's diagrams and there's descriptions and there's vocabulary words with, boldface words, and it's not exactly the text, but it's kind of like text incorporated with a couple of practice questions to make sure you're on track. And so if you're working through something like this 2.1 lesson, and I saw more than half of you already finished this, so I'm not going to spend a lot of time on it. It is due tonight. You can see there's a description of what's going on, and it is kind of like a self-teaching lesson if you want. You could do this on your own if you read through it carefully, but I don't want you to be teaching yourself. You signed up for a class with an instructor and other students, but whether it's you need to do it on your own because you missed some classes or you just want to look ahead, whatever it is, these lessons are something where there's enough information where you can get at least a good idea of what's going on, but also all the information that's in there can be used to supplement what we talk about in class. So like this problem, there's little animated things also. I think I showed this one on Tuesday, but it was just talking about, which of the following are quantities in this situation? And up above, it had been describing what quantities are. So in any case, quantity is an attribute of an object or a situation you can imagine measuring or assigning a number to. The value of the quantity is a specific measurement. So it wants to know which of these are quantities. Oh, okay, well, not the color of her house. That's not something I'm going to assign a number to. I mean, I guess there are numbers that you can assign to colors for computer programming purposes, but that's not a measurement number. That's just like a zip code. It's just kind of a descriptive number. Distance from the house, Joe walking toward her car. Well, that's just kind of an activity. That's not something that has a number associated with it, like how many walkings to her car do we have? So just deciphering what is meant by a quantity, and then values of the quantity, fixed versus varying quantities, so things that are changing relative to something else, or just that change, versus things that don't, like the length of Joe's car probably is not changing. We hope not. If it does, probably because she ran into something, got shorter. Her distance from her car, well, if she's walking, then yeah, the distance from her car is probably changing. That's a changing quantity that we could measure. At one point, it's going to be a longer distance than another. So these lessons, they have, tips and definitions and lots of description in them. On the other hand, as you saw, there's also for 2.1 now a homework that's available. Now the homework is due by Friday night, same time as the PCA, the pre-calculus assessment, that's not graded, but I just want you to do your best on that. This is kind of get a baseline of where we are at the beginning of the class. We'll have a post-test also. Again, also doesn't count in your grade, but just please do it, take it seriously so we have an idea of what we're doing well in the class and what we need more work on. But in any case, this assignment due tomorrow is not wordy. It's just got questions with answers to sometimes pick from a drop-down, some to fill in, and there's not all the text in between and descriptions and definitions, just enough words in the questions to describe what we need to know in order to answer it properly. So, and all these things, and I got to here by clicking on the module 2 on the main page of this. There's a lot of announcements right here. I do want to talk about that time zone thing in a second, but down at the bottom of this page, you'll see each of the modules. Most of them you won't be able to see much in right now, other than that they exist. Click on 4, and you can see the list of things, but there's nothing to see in it yet because it's not available. I will make them available when they're getting closer, but in Module 2, Sections 1, 2, and 3, which are things that we're working on this week, all those materials are available. There's lessons for all 3 sections and homework for all 3 sections that are now available. And you can see, so there's nothing from 4. But you can see those all on the calendar also. So you don't have to scroll down to that to see your assignments. You'll see them on the calendar, but notice that some say HW, that's the homework. And LN, those are the lessons. So those are going to be due earlier. And those are things that we'll do some of the questions from those during class or talk about them. The homework, typically not. But in any case, this is where we're going to find this iMath is where we're going to find the graded work from the class. And the main textbook site that's associated with it. This is your workbook in electronic format. How many of you already have the bundle and access sorted out? I know it's like not everybody has all the access sorted out, but make sure you get that as soon as possible, because as you saw on that calendar, we do have this 2.1 that's due tonight, and that is in the iMath section. If you haven't purchased your access, you won't be able to get to this site just yet. Now, as I did talk about on Tuesday, you'll have 20 late passes you can use. Late passes are pretty simple to use in terms of if you try to get to an assignment and it's past its due date, you click on it, it'll give you a message that says something like, this is past its due date. Would you like to use a late pass if you have any available at least? You can click yes, and it'll take you back to where you started, but it'll just say that you have an extension now, and then you can click on it and go in and work on it. So, in any case, if you do miss something and you want to use a late pass to get credit for it, you can. These lessons and homework are different sections of your grade. They're worth different percentages according to your syllabus. Well, they're different components. I think they're actually worth the same amount, but in any case, the lessons and the homework, and we'll also have some quizzes every once in a while, including, we'll have one after class on Tuesday next week. I want to make sure everybody's had a chance to get into the system. But after class is over on Tuesday, I'll open up a quiz for you to do sometime during the rest of the day on Tuesday. Doesn't matter if it's like right after class or sometime before midnight. It's just going to be over what we've talked about from the beginning of chapter 2. So up through probably what we talked about today. Just to give you a chance to get acclimated, make sure you know how all of this is working. So, speaking of how all of this is working, if you could please get into this 2.1 lesson just as an example, and to so we can kind of wander around. I want to wander around, see if you have any questions, getting stuck getting into things or know how to answer things. Go into 2.1 and this lesson, and scroll down past the house and the car, down to the, where are we? Sorry, it's a little ways down. The Ferris wheel. So example 2, the Ferris wheel. What I'd like you to do, you can do this on your own if you want, or if you, I would say, talk with a neighbor, but see what you can do to answer the questions on the Ferris wheel. This is kind of basic descriptions of, on this when we're talking about quantities again. You'll see there's several questions all about this Ferris wheel. Values of these and what's varying and what's not. So this is questions, I guess. They're numbered here. 7, 8, and 9 are all about this Ferris wheel situation. So take a look at this, and I will wander around, we will wander around, and see if you have any questions, either just technical, like how do I get to this? Again, this is lesson 2.1 in iMath, the one that's due by 11:59 tonight. I just want to make sure everybody can get in it and you're not stuck and know where you're supposed to be going. Discuss with the neighbor, You can obviously like enter these and see if you get them right or wrong. These have infinitely many tries and you don't get fewer points based on how many times you get them right. But I hope it doesn't take you infinitely many tries because that would be an awful long time. And if you don't have your access yet, if you can maybe, look on with someone else, I don't want you to like get too close to the regular or anything, but just maybe look with someone else nearby.
No, that's not sectarian.
So you can see what the questions are, pass this one on, move this up and I'll look at it. I'm going to make this a little bigger. I did want to point out that the majority of the content you can still see and I see a few people doing this around the room. You can still see just on a cell phone. So if you don't have a laptop to bring to class with you, or yours is not charged or something like that, you're not necessarily out of luck if you do have a cell phone. I would say, get your password in there if you don't have the same browser bookmark saved. Whatever it takes to get in there. I know Canvas is a little bit touchy sometimes on phones, but if you have this bookmark specifically, you can get there on the browser. And it works pretty well once you get to the right place. You can see the diagrams, the animations still work. But I do want to talk about this a little bit just to make sure we're on the right track, and then we're going to move on and talk a little bit more about some other details. So the first example that we talked a little bit about on Tuesday, just her walking to the car, and we talked about some basics. This has some more bits and pieces involved, some more things to worry about. And the reason that this is in here as an example is to make sure that you think about carefully defining your quantities. So if I wanted to talk about, let's see, it says, suppose Kristen's on a Ferris wheel in a bucket at the 3 o'clock position and rides around the Ferris wheel for 1 full rotation. So that's when this keeps stopping when she's in the 3 o'clock position. Ferris wheel has a radius of 10 meters. The center is 15 meters above the ground. That sounds like a lot of information. It's like, what on earth are we doing with this? Well, keep it in mind. So the first question, which of the following are quantities? Of those first 5, Kristen's height above the ground, the color of the Ferris wheel, her height above the center of the Ferris wheel, the radius of the Ferris wheel, and the type of Ferris wheel. How many of those 5 are quantities in this situation? Those of you that already did this might know how many of those 5 are quantities. Yeah, it should be 3. Remember, quantities are what? Can someone describe what it means for something to be a quantity? How? Yeah, it has something we can measure, a mathematical amount. I heard something else over there. What was that? Yeah, so quantities are things, aspects of a situation that we could measure and assign numbers to, some sort of measurement. So let's see. Height above the ground, quantity or not a quantity? Quantity, yeah. Height above the ground, we could measure that. Maybe in feet, maybe in meters, maybe in millimeters, whatever you want to measure it in. Some sort of length type measurement, linear measurement. Color of the Ferris wheel. Not a quantity. Color, I don't know, how do I measure a color? Well, there's ways to measure it, but that's not what we're talking about. We'd probably say it's red or it's green or it's silver or it's whatever it is. Kristen's height above the center of the Ferris wheel. Yeah, that's a quantity. The radius of the Ferris wheel? Quantity. Yeah, and all of these 3 that we've picked as quantities so far, and we said there were only 3, so I'm guessing you say the type of Ferris wheel is not a quantity. These are all the same sorts of measurements, some sort of linear measurement, meters, feet, inches, millimeters, miles, pick some sort of length measurement, distance measurement, and that's what we would measure these in if I wanted to do more with them, which we probably do. So it says, which of the following quantities are fixed and which are varying as the Ferris wheel spins? So it's telling us that all of these are quantities, so which of the following quantities are fixed. So of these 5, let's see, the total distance Kristen has traveled since boarding the Ferris wheel, the height of the center of the Ferris wheel above the ground, Kristen's height above the center of the Ferris wheel, Kristen's height above the ground, and the radius of the Ferris wheel. Of those 5 things, let's see, which of the following are fixed and which are varying? How many of those 5 are fixed quantities? 2 of them. What's one of the 2 fixed quantities listed?
The radius of the Ferris wheel.
Yeah, radius of the Ferris wheel. That is not changing. That'd be a really scary ride if it were. All of a sudden, Ferris wheel gets bigger or smaller. Hey, surprise, you're really close to your neighbor. No, radius is not changing. Let's see. Oh, wait. Total distance, height of the center, height above the center, radius. There we go. Radius is fixed. There's one other one that's fixed.
The height of the center of the Ferris wheel.
Yeah, the height of the center of the Ferris wheel above the ground. also fixed. If it weren't, then the Ferris wheel would probably be rolling down the, dropping. That would be a bad situation. These other three are varying quantities. She's traveling around and around and around, so that distance that she's traveled is changing, increasing. Her height above the center of the Ferris wheel, sometimes it's a lot, sometimes she's equal with it. She could even be below it. We'd maybe use a negative number for that. Height above the ground, well, that one wouldn't be negative, but sometimes it's larger and sometimes it's smaller. What's the smallest that her height above the ground could be? The Ferris wheel has a radius of 10 meters. The center of the Ferris wheel is 15 meters above the ground. While she's on this, what's the closest she's going to be to the ground? Yeah? 5. Yeah, so what's the farthest she's going to be from the ground? Yeah, we've got a radius of 10 meters, and then 5 meters down below. So 5 meters to here, 10 meters to be all the way up to the top. So yeah, her height above the ground is varying from or between 5 and 25 meters. And all those numbers kind of work together to give us that, but she's between 5 and 25 meters. When she's equal with the center of the Ferris wheel, she's equal to its height above the ground, 15 meters above the ground. Does it say that? Oh yeah, I guess it says the center of the Ferris wheel is 15 meters above the ground. Yeah. So in any case, last question about the Ferris wheel. I think we talked about pieces of this in a way, not these specific numbers. And oh, by the way, not everybody necessarily has the exact same numbers on these numerical questions like this. They might vary from person to person. Most of the ones in the lessons stay consistent, but on your homework, when they ask you to compute things, one person will have one number and another have another. Same way to solve the problems, but just different results for different people. So just be aware of that. If you're working with someone, you might not have the exact same numbers in the homework questions at least. So the radius of the Ferris wheel is 10 meters and the center is 15 meters above the ground still. So if she's 4 meters above the center of the Ferris wheel, what's her height above the ground? 19. Yeah, 19, because we've got 5 to the bottom of the Ferris wheel, then 10 to the center of the Ferris wheel, and then 4 more, right? So I didn't want to belabor this assignment too much because like I said, I know more than half of you had already done it prior to today. But just to kind of, the idea of this is to fully think about the situation. And there are a lot of details in this question. We don't have to discover everything possible in order to answer this, but there's just a lot of numbers at the beginning. Make sure you keep them all in mind as you're working through, although as you saw, this is like the lesson part. It reminded you of these key points about the radius and the center right there, so you could remember what's going on there. In the homework, there's typically, it's all one question that's together as opposed to spread out over several questions if there's one scenario or one descriptor example that goes with it. So you don't have to scroll back 4 questions to figure out what the radius that you need to use was. It'd all be linked in one question with multiple parts for the homework. But let's talk about a little something else. What I'd like to do, I'm going to go to the textbook. Here we go. Or workbook. I'll call it a textbook. It's a textbook / workbook. But take a look at investigation number 2. And there we go. So investigation 2, module 2, section 2 is about something else we talked about briefly on Tuesday. Thinking about how quantities change relative to one another. I'm trying to remember what exact example I was using on Tuesday. Thinking about moving over time and 40 meters and in 30 minutes or something like that. So we're or 30 seconds maybe. I don't remember what it was. 3 minutes? I think it was 40 meters in 3 minutes. So we're shuffling to get there. Talking about how time is going on. We don't get to think about time changing, but time was changing and distance was changing. We can talk about a constant rate because of that. But module 2 investigation 2 here, Scroll past question 1. This is kind of weird expressions. But take a look at this number 2. Now, one thing I want to point out about this, and let me see if I can make this. There we go. We're using this symbol D, and it has a subscript on it. I know it's a little hard to see if you're in the back, maybe even in the front. But this says D with a subscript of T. So we have 2 different distances that we're using. And D is nice to use for distance, but I don't want to use the same symbol, the same variable, to represent 2 things that aren't really the same. So this D with a subscript of T represents a number of feet that a tortoise has crawled north of the starting line of a race. A lot of details. D with a subscript of H, the number of feet that a hare has traveled north of the same starting line. Rabbit. But tortoise and the hare, kind of fable story, whatever. What do each of the following expressions represent? So there's some expressions with DTs and DHs there. I'd like you to take a look at question 2 there. We're going to talk about these more in depth because these are a little bit, well, things we haven't talked about entirely yet, but I think that they're related to the sorts of things you've done before. And I'll scroll this down so we can all see this. Number 3 and number 4 is what what I want us to look at. So I'll leave it on 2 for a minute in case you don't have access to this yet. And I'll scroll up in a little bit, but 2, 3, and 4, I'd like you to take a look, see what you can do with those. 2 is about tortoise and hare distances. 3 is about the relationship between the circumference of a circle and its radius. And number 4, about Becky and Wendy walking toward one another, and we're using a couple of different descriptions of their distances. So I'll leave this 2 up there in the top of 3. If you don't have access to this all quite yet, take a look. Maybe you can see this or look on with someone else. Yeah.
How would you navigate from the lesson to there? Because I don't see.
Oh, so it's not on here. It's on the rational reasoning main website. So you can get there going back to the. Go back to the that page. Just click on that. Yeah. And then just log in. And it should be pre-calculus calculated. Yeah. And this is module 2. Oh, yeah, sorry, it looks like it expands, but it doesn't. And then it's an investigation 2. Oh, let's see. So, okay. Oh, so this course enrollment key, that's in the syllabus. Let me, I don't remember what it is off the top of my head. Hold on just a sec. I'll put that back up in a second. If you're trying to enroll, the course ID is 2826. I'll write this on the board. And then the enrollment key is that 170 J Bonnie, so that's my initials. All right, sorry. Oops. Which one? This one. There we go. So after you've had a little chance to work on these, I'm going to kind of ask for more individual input on these, as opposed to me doing most of the talking. I want you to get some practice at describing. these first few sections, I think maybe the concepts seem simple. It's more about getting used to how to explain what you're thinking that I want you to focus on. Okay, so this is in the textbook as opposed to, so if you go back to the Canvas page, just follow that link and then log in. Yeah, plug it in and there's two links on that same page. One of which is the textbook, the other is that one there. So it's the top of the tablet. And then this is multiple investigation. Alright, so if you go back to the, National Science page, click on that restoration.net, and then log in or sign up. Okay, sign in, I guess. Mine does the same thing, it doesn't show up, I just click one of those blank spots. Oh, there you go. And then it's this pathway to capitalism. And then this is module 2 investigation, and 2 investigation. So some of this stuff that we're looking at right now, if you're confused about what's being like, how do I interpret this? Think about, maybe when you talked about in class long ago, what can subtraction mean, or what can division mean, or what can multiplication mean? Like that seems maybe silly, but if you're thinking like, well, what do I mean when I divide? There's some other things you've divided. Think about what that could be representing. So it's the 2 different ways to interpret. And well, I just need one. See what else you can think of also. If you are stuck trying to figure out where this is, let us know. There's a lot of things to click on in different places to go in this class. They're all very similar. I want to make sure you know where the text or workbook online is in addition to just the homework page. Alright, so there's not a link to it on here if you go to the main Canvas. All right, I'm going to scroll this up to number 4. So you can see at least parts of it. You can see 4A through C at the same time. All right, let's talk about these a little bit. So, all right, first of all, if you didn't catch what I was doing, if you just joined the class recently, this is in the syllabus, this information here, in about 3 or 4 different places, all highlighted in various colors. But when you do go to register for the iMath AS and Rational Reasoning site, it's going to ask you for a course ID and an enrollment key, and that's what these are for. So if you haven't used those yet, they are in the syllabus. Like I said, there's there at the bottom of the page, probably someplace else. There's another place that it is. All this highlighted stuff in the syllabus, it's that. So it helps you get in if you haven't yet registered. If you have registered, you don't need that information anymore unless something happens and you need tech support, but I have that information and it's in your syllabus. So this section about representing quantities and changes in quantities. Again, I want to go back to like where on earth I am in this, just to point that out again. So as I said, the Canvas page is just page, singular page. It's there. If you get lost, you can click this Rational Reasoning website link from the syllabus or from the Canvas page. It'll take you to this page where you either sign up or sign in, depending on what you need to do. Log in. And on this page, yours doesn't have quite so many links. It has 2 out of these 3. You don't get to set up your homework, but you'll see this Pathways to Calculus 8th edition, Instructor edition, and online homework down here. There's another link to the online homework at the top, but this is where you get to the workbook online, the textbook, workbook, whatever you want to call it, with these investigations. It's this link here. And what we were just looking at, and I'll open up again, was Module 2, Investigation 2. And yours doesn't say student and instructor, it just says the investigation. So that's where we were. And this Module 2, Investigation 2, if you want to think about how that corresponds to what's in the homework, this is in Section 2. If you go to, let me just go down here, Module 2, Investigation 2 corresponds to this lesson number 2. This talks about a variety of things. But some of them are, let's see if I can get to this. Introduction to operations. So normally speaking, with like stuff that I think is brand new material, we want to go through we'll talk about the lesson material first, or I'll have you look at the lesson material before class. And then we'll do some investigations in class after summarizing that and maybe answering some questions about it. And the lesson will be due like after class where we've talked about it. And then after you've gone through this lesson, which this has some of the same sorts of things like, here's the C equals 2 pi r. And what we were just dealing with it's like draw a circle and label its circumference. Every circle has the same shape. We know the circumference is always 2 pi, or about 6.28 times as long as the circle's radius. Same sort of information that was in the question that we just saw in the investigation. So these are linked. It's not like completely separate stuff, and all the numbers match up. So Module 2 Investigation 2 matches up with Section 2.2 in here. They're on the same topics. This talks about those operations and the relationships and what those mean and interpreting those. And then this other part, which we haven't gotten to yet, but defining and using the dependent variable, which is just about assigning more letters to things that are varying when we want to describe how two things are related to one another. All right, but in any case, back to this investigation. So there we go. So if d sub t, the d with the subscriptive letter t, represents a number of feet of tortoises crawled north of the starting line of a race, and d sub h represents the number of feet a hare has traveled north of the same starting line, what do each of the following expressions represent? Now, before we go answer any questions on this, I just want to point out, notice how we have this symbol d sub t. It's representing this distance that something's traveled. It's representing a fixed quantity or varying quantity? Varying quantity. So this is a variable, d sub t, and d sub h also a variable. It's a symbol representing a varying quantity. But those are defined really carefully. D sub t represents the number of feet, we talk about our measurement units, that a tortoise is crawled north of the starting line. So if I just said d sub t is the tortoise's distance, that kind of is part of the information I need to be able to do anything with d. So make sure if you're defining a variable, make sure you define all of it. So we need units of measurement and precise description of what's going on so that someone else could take this and use it. So if I say d sub t is the number of feet a tortoise has crawled, that's okay, maybe slightly better, but I need to know relative to what. So if I say d sub t is 9, it's like, okay, that's great. So if I saw that, then the tortoise had crawled 9 feet. But where was it to start with? If I need to relate it to something else, d sub h. If I want to subtract these, what does that even mean if I don't have a thing that these distances are measured with respect to? So in any case, d sub t minus d sub h. Anybody have a description of what that could mean? Yeah.
The distance from the starting line the tortoise is in relation to the hare?
Okay, the distance that the tortoise
is from the starting line in relation to the hare from the starting line.
Okay, so if I said d sub t minus d sub h equals 9.
The tortoise is 9 units ahead of the hare from the starting line.
Okay. So yeah, 9 units ahead. So relative to, if it's positive, would mean ahead. And what if this came out d sub t minus d sub h is -7? What would that indicate about their distances relative to one another? If it came out negative?
The hare is 7 feet in front of the tortoise.
Yeah, if this came out negative, that would mean the hare is in front of the tortoise. If it came out positive, the tortoise is in front of the hare. Those positive versus negative, and thinking about what they mean, if you can't figure out what it means, it could be because you haven't, like if you're making up a problem and you can't figure out what the subtraction means, or positive versus a negative means, it could be that you don't have a definition quite all the way done, like north of the starting line. So if you're stuck trying to read someone else's description, one tip I would say, try to draw the situation, especially if there's a lot of details and several different things that are moving. It might be helpful to draw a quick sketch, doesn't have to be beautiful. But, okay, starting line. I'll just do this on the board today since I'm still working on the other software. Starting line. Here's the starting line. North. Let's say that's that way, typical map notation, up. So if I have tortoise and the hare both going this direction, I'm assuming they're both going to try to go that direction, but maybe the tortoise is gotten to here, and the hare has gotten to here. Doesn't matter how far they are left to right from one another on this starting line, if these d sub h and d sub t are talking about their distance north of the starting line. So it's not the so if we're talking about describing d sub t minus d sub h, it's not necessarily the distance between them, but it's relatively which one's farther from the starting line, where a positive result would mean that the tortoise is ahead. The first part of the subtraction is bigger than the second. A negative result would mean that the hare's ahead. So drawing something like, as non-artistically skilled as that, you might even realize, oh yeah, it's not the distance between them, it's who's farther from the starting line, right? And or how far ahead is one of the other in terms of how far they are relative to the starting line. It's not how far are they apart, unless they started in the exact same spot and are moving forward like that, which that's not usually how races work. This is how much farther one is relative to the other. Now what about B? Let's see, what do we have here? D sub t divided by 12. That's maybe a weird looking number. Any thoughts?
I'd say converting the distance that the tortoise has crawled into inches.
Let's see, dividing by 12. So if I have the number of feet and I divide it by 12.
Oh, never mind.
Yeah, so multiplication by 12. Yeah, 12 is kind of a weird number. But it's like, all right, multiplication by 12 would do our converting feet into inches and tell us about our tortoise. So is there anything about 12 in this problem or anything else that is special about 12 or no? Like I'm dividing? Yeah, thought?
It's just a 12 of the distance the tortoise is traveling.
Yeah, if it were, like I said, if it were multiplication, we could maybe think, oh, maybe that's something to do with I can convert this to inches and talk about that, the number of inches. But yeah, division by 12 is going to make a smaller number. So yeah, it's 1/12 of the distance that the tortoise is beyond the starting line, north of the starting line. So whatever it is, I could say it's 1/12 of the distance, measured in feet still. Again, if it were multiplication by 12, we could talk about the number of inches, or we could just say it's 12 times the distance in feet. There's different ways that you could define it, but just trying to come up with, why would I be doing this calculation? So why would I be doing this last calculation? D sub h divided by d sub t. Any thoughts on what that could mean? Let's see, you've already, anyone have a thought on just what this division could mean? All right, go for it.
So if it's the distance the hare has run in relation to the distance the tortoise has run, if it's like a race, that reminds me of like betting odds and stuff in general, like there's an advantage or disadvantage. So if the tortoise has gone like 20 meters and the hare has gone 30 meters, that's a 33% like rate at which it's faster than the tortoise. So like I just think of live betting odds, I guess.
Okay, so like a percentage sort of thing,
Yeah,
only
like
there's not a times
percentage
100
or
here.
A percentage or a ratio that one is ahead of another variable or behind another variable.
Yeah, good. And I also like the way you described that in terms of, like, suppose that this was 30 and that was 20. If you're not sure, like looking at expressions with variables, what it could mean, imagine a specific case, pick some numbers and see what that might mean. So what if this DH was 30, meaning 30 feet north of the starting line, and this was 20 feet north of the starting line. And we divided those, it's 1.5. Oh, 1.5, like 30 is 1.5 times 20. So maybe the hair is 1.5 times, has gone 1.5 times as far as the tortoise. Sorry, I was forgetting which one was which. Or 150% of the distance, if it was that. So if it's not 30 and 20 or 1.5, we just talk about how many times as far one is traveled than the other. Or, and the danger of making up specific numbers is realize that the top number doesn't always have to be bigger, right? It still makes sense, like if this is 10 and this is 50, if you know the story of the tortoise and the hare, Hare's kind of lazy, he's kind of hanging around like, yeah, no, whatever, I can beat him, I'll be faster, so I'm going to take a break, not go very far, maybe I'll go back over here, have a snack. Meanwhile, the tortoise trudging along slowly, but maybe gets farther, almost to the finish line. If this is 10 and this is 50, I could still say it's a relative, it's a ratio of their distances traveled, or I could still even say it's how many times, if that would be what did I say, 10 and 50? 1/5. The hare has traveled 1/5 the distance that the tortoise has. So you can still talk about it as a ratio. You might not say how many times as far, you say 1/5 as far. Well, I guess that makes sense. But just keep in mind, if you are making up, it's a good idea when you're trying to figure out what an expression means to, well, what if these were specific numbers? What does that mean? Or if you're trying to set up an equation for something, same thing. Let's see, well, what would I do if I had numbers for everything? Oh, I'd subtract these and divide by something. Always a good idea if you're stuck. Try it with specifics instead of just trying to use symbols all the time. But keep in mind that they don't have to have the relative values that you might have picked as that example, like bigger versus smaller, or positive versus negative, and maybe in other cases. But yeah, so subtraction and division, what we covered here, talk about a difference between two things, or a ratio, or relative, how many times as big or small something is. So thinking about that, number 3 here, we've got this circumference is 2 pi r. Great, geometry formula, learned it a billion years ago, right? So as long as we're measuring the circumference and the radius in the same length units, like both inches, both millimeters, both miles, whatever they might be, this formula works out great. So looking at these questions then, we've got a formula, C equals 2 pi r. The circumference of any circle is blank times as large as the circle's radius. What goes in that blank? 2 pi, right? Circumference is 2 pi times the radius. 2 pi being about 6.28. Alright, so then question B, the radius of any circle is blank times as large as the circle's circumference.
30.5.
What was that?
30.5 times.
Yeah. Let's see, radius and circumference. I think you're thinking radius and diameter.
Yeah.
So radius and circumference, same kind of idea though. So it's the same two pieces as we had in part A, but just stated in the other order. Notice. So the circumference is 2 pi times as large as the radius. The radius is, huh?
0.5 pi.
Not quite. 0.5 pi, I like the 0.5 part of that, but it's the whole, where did you get the 0.5 from?
I just did it backwards.
Okay, so backwards, the 1/2, the 0.5 is like 1/2, backwards from 2. So what's the word we're looking for instead of backwards? Reciprocal. So we don't just need the reciprocal of 2 though, we need the reciprocal of 2 pi. So, yeah. Yeah, 1 over 2 pi, which is, no idea what. Kind of like 1/6, 1 over 6.28. Some weird number, so probably about, I don't know, 0.15 or something. But if the circumference is, let's just use round numbers. If I say the circumference is 6 times as large as the radius, then the radius would be 1/6 times as large as the circumference, right? So it's not as nice a number, but we can still do the same sort of flip-flopping reciprocal to describe this. So the radius is 1/2 pi, like 2 pi both in the denominator, 1/6.28ish, times as large as the circumference. And in the first sentence, maybe it's easier to think of because it's like, you know, whole number, the circumference is actually bigger than the radius. Whereas we say, how many times is large? And well, it's not larger, it's smaller. But we can still say how many times is large and have it be a number less than 1. Because I can say this is, you know, 1/3 times as large as something else. That just means it's 1/3 times that something else. So thinking about C and D, I've got some expressions with division here. We did a little bit of dividing, doing reciprocals. But take a look at C, part C, describe at least 2 different ways to interpret what C, circumference, over 2 pi represents. Well, what's one thing I could say about C over 2 pi? Anyone?
It equals the radius.
Yeah, C over 2 pi equals radius. How do you know?
Because the radius is.
Yeah, that's our formula rearranged algebra-wise. C equals 2 pi r, so C divided by 2 pi has to equal r. That's a formula that we have. That's algebra that we've done before. All right, now what does that mean, though, in terms of interpreting division? What's something else we could say about that besides that it means that it's the size of the radius? I know its value would be whatever the value of the radius is for a particular circle. Well, think about maybe just what the meaning of our division is. If I divide something, I don't have whole numbers, so it's not like, okay, I have 40 candy bars and I'm going to divide them among 3 people, and what do I have left? I don't have 3, I have a weird number in the bottom. But if I'm dividing,
Like a part.
yeah, figure out how many of those parts go into that holder. So how many 2 pi's are there in a circumference, right? How many times as big as 2 pi is the circumference? Kind of like the, let's see, what was the hare and the tortoise question. How many times as far did the top number run compared to the bottom? We can think of these divisions as the same. How many times as large is the top as the bottom? So if this division here came out to be 7, then I know that the circumference is 7 times 2 pi. And when you say it that way, it's like, oh yeah, well if this comes out to 7, and remember we said this is equal to the radius, then the circumference is 7 times as big as 2 pi. 7 times 2 pi, which circumference is 7 times 2 pi if the radius is 7. So sometimes it's just, even if you weren't sure what you were going for, if you just try to say some things out loud or write it down, type it out, whatever you're doing, once you start putting the words together, maybe you might make a discovery that like, oh, you start writing, it's like, oh yeah, that's exactly what this formula is. It's just a different way to word it than circumference is 2 pi times the radius. Well, the circumference relative to 2 pi is going to be r times as big, because we said c over 2 pi equals r. But c divided by 2 pi tells you how much bigger, how many times as large c is compared to 2 pi. And it could be a smaller number. C could be something like 2. And I know 2 pi is 6.28 all the time. But that still tells me how many times is large. And whatever that ratio is, how many times is large, that's still the radius every single time. Because that's the other way we can interpret this. Oh, I know the relationship between these two based on the meaning of the symbol c is circumference of a circle and 2 pi, and that's related to the radius. Alright, so what about d then? C over r. What's a value for that? All the time. 2 pi. Yeah, this C over R is actually a fixed quantity in the context of C stands for circumference of a circle and R stands for the radius of the same circle. It's always equal to 2 pi. No matter how big one or the other of those is, they're going to be in that same ratio. But in terms of interpreting this division, just the meaning of it without knowing the value of it, yeah, the distance around the circle relative to the distance from the center of the edge, the radius of the circle, it'll tell you how many times is large. How many times is large C is relative to R. How many times larger C is than R? I know this one's going to be greater than 1. In fact, we know it's always 6.28 if we think about it a little bit. But yeah, C over R is the relative size of the circumference to the radius of the same circle. That's the meaning of those letters here. But just in any context, even if this weren't about circumference and radius and they just happen to be these two letters, I could say that this division, C divided by R, how many radii fit around the circumference of a circle, but I could always just say how many times as big C is than R, or how many times larger C is than R. All right, so let's see. Part E is an art question. You have to draw a line. Yeah, question.
No, I was gonna say, isn't it just gonna be like twice the size of that?
Let's see, given the radius, construct a line segment with a length approximately equal to the circumference. How many times larger is the circumference than the radius? 2 pi. So about 6 times as long, right? So say, all right, so however long this is, and on your paper, maybe it's like on my screen that looks like a little bit more than an inch, but on there it's about half a foot. But if I wanted to draw something, if this is the radius, I don't have to draw a circumference in a circle, although I could try to even draw a circle around that. But if I just want to say, well, how long would the circumference be, an unrolled circle, it should be a little bit more than 6 times as long as that. So just relatively speaking, you could figure out, all right, use your little map key, 6 of those in a row, there to there. So I just realized the length of a circle could be measured, I could unroll the circle, lay its circumference out in a straight line, like cut it, roll it out. It could be measured in a straight line also, but it would have to be 2 pi times as long, 6.28 times as long, or a little bit more than 6 times as long, since we're just doing a quick estimate. All right, so I'll stop at that for today, but what I want to, get back to, I want to point out what I'd like you to do coming up. So, stuff to do between now and the next time I see you, which will be Tuesday. You've got the 2.1 lesson, which in red on the screen. It's hard to see, but that's what's on today's event. That's due tonight by 11:59. Tomorrow, before the end of tomorrow, make sure you take that diagnostic pretest. I don't have access to see what your scores are or how many. Hold on, sit. Wait just a minute. It gets loud in here really easily. The diagnostic pretest, I can't see the scores on it. It takes you to an outside page. I can't see your scores on it. So I don't know who's taken it and who hasn't taken it. So just a general reminder, please take the diagnostic pretest. Do your best on it. This isn't something to study for. It's just, I want to see what you know. And if you don't know it, you don't know it. If you do know it, great. And then at the end of the semester, I'm hoping that you know more. Hold on. But you can see what we've got coming up. 2.1 homework is due by tomorrow night. If you're having trouble, please visit the forums. There might be questions already posted there by the time you're there. There weren't any yet this morning. But this 2.1 homework, if you click on it, there's a bunch of questions, 11 questions. And they're all related to the 2.1 investigations, the 2.1 lesson that's in the same thing. They're all similar sorts of topics. This is about fixed and varying quantities and covariation, variation alongside something else of quantities. That's due by tomorrow night. I just kind of spread this out so that everybody has a chance to get acclimated, but all this is things that we talked about this week. So 2.2 and 2.3, take a look at that. 2.3 is, we didn't talk about that specifically, but it's pretty closely related anyway. 2.2 and 2.3 lessons are due by Monday night. Now, this is a 3-day weekend, so just keep in mind Monday you're not going to have classes. We weren't going to meet on Monday anyway because it's a Tuesday, Thursday class. But those who do, I just have them do Monday night. This 2.3 lesson, just see what you can do with it. I think you'll find it's not too hard. But in class on Tuesday, we'll recap a little bit more with 2.3, like in specific, spend some time on that in here, and then go on to the next couple of sections as well. And you'll see some more lessons and homework populate. It's not going to, like I said, it's not going to be too far out in the future because I don't want you to try to like skip ahead and do stuff all before we get to it in class because I want us to be able to think through some things together. But this is just what's coming up. Like I said, the green here, I don't know why these things are green. I don't know what's wrong with that square. But in terms of these, this 2.2 and 2.3, those are farther off in the future. These are closer, that's why they're orange, and the one that's due today is red. Just kind of stoplight, pay attention, warning, whatever. But if you do have questions, post questions to the forum, message me in Canvas. The tutoring center for Pathways, we're still sorting out the hours for that, but we should have those together and organized for me to give you in class on Tuesday next week, so we know when it is. All right, have a great weekend, enjoy yourselves, and good luck with the rest of the week.